Let's now take a look at how we can use init containers to set up the state of our pod the way we'd like to. As always, let's start our demo with a quick look at the state of our cluster. If we run kubectl get pods, we find that we have two pods up at this point. The first is our deployment, the other is our front end pod. So far, so good. Let's now go ahead and open up a YAML template file. This is going to be a rather complicated YAML file because we are going to specify not only an app container, but also the init containers which have to run before the app gets going. The API version is v1. The kind of the object we are seeking to create is a pod. The metadata, which includes the pod name, has been set to be equal to init demo. So far, so good. Let's now take a look at the spec of the pod. Within this, notice how we have a containers field, and then down below that we have an init containers field. We'll get to the init containers in a moment. Before that, let's just focus on our app container. As usual, this app container is an Nginx image. So this is going to be pulled from Docker Hub. This container is going to make itself available on the container port 80. And then something else a little different. Notice there is a volume mount. Volume mounts are used in order for our containers to access certain specific abstractions for storage. Here, this is a work directory which has been mounted at the path user share nginx/html. And as we shall see, we are going to place a very specific file within that working directory by running a wget command. And that is exactly what the init containers are going to accomplish. Remember that the init containers run before the app container comes into existence. Here, the first init container and the only init container, in fact, is an install. This is going to install the busybox image. And what's more, it's going to make use of wget, which is a handy utility for hitting websites from the command line. This is one of those utilities included in the Swiss Army knife like busybox image. We are going to call wget -o followed by a specific location, that is workdir/index.html. And what are we going to store in this particular file, in this index.html? Well, we are going to store the contents of a website, specifically the kubernetes.io website. What's really interesting is that this is the same underlying file which we mounted in our app container. In other words, we are using the init container here to get the contents of a specific directory into exactly the shape that we want them for our app container to take over. In order for that directory to be available to be mounted by the various app and init containers, we need a specific volumes field. That's what's present at the very end of the YAML specification. Here we are creating a volume which is of type empty_dir. Empty_dir is a non-persistent volume type which is effectively going to create an empty directory which will have the same lifetime as the pod. In contrast to non-persistent volumes like empty_dir, there are also persistent volumes where the underlying storage will persist even after the lifetime of the pod. More on that in a bit, but before that, let's go ahead and actually execute this template. Once again, we are going to make use of kubectl create -f. This is our usual preferred way, which is neither purely imperative nor purely declarative. The control plane is going to go ahead and parse the contents of that YAML file and create the init demo pod. Let's now go ahead and list all of the pods in our cluster using the familiar kubectl get pods. And this time we have an additional pod which is the init demo. It's now running and it has been running for 11 seconds. Now let's establish a shell into our live container. This is an interactive shell which we set up using kubectl exec -it. As always, we want this to be a bash shell, and so we specify the bin bash command. As we'd expect, the command prompt changes because we are now running as root inside this pod. This is why when we run commands like apt-get, we do not need the sudo command ahead of them. So let's go through a familiar set of steps. We run apt-get update. That goes through successfully. Then let's go ahead and install curl. That is going to require some additional storage space. which we might be prompted for by the underlying cloud abstraction. We hit yes, it keeps going through and it's done successfully. Now remember, the point of this demonstration was to check the use of the init containers, and we had an init container which was going to populate a specific file with the contents of the Kubernetes website. That specific file was going to be available in the file system, which we can check by using ls. So let's type ls user share nginx /html. There is an index.html file. If we go ahead and cat this file, we would find the contents of the kubernetes.io website. But let's do something even better. Instead of catting the contents of that file, let's go ahead and curl localhost. And we know that when we curl localhost, we are going to be directed to the container port, which is 80. And there indeed, we find exactly what we expected to see. We have the HTML, which corresponds to the contents of kubernetes.io. And in this way, we have successfully used an init container to populate a specific file within our app container with the contents of a website.